Okay, so we just done the first questions and I have cleaned to have more space to solve the next question. Use the work energy theorem to find the maximum height the rock will reach. So how can we find it? I really like this kind of phase to plan strategies how to solve the problems. So let's see what they ask us to do. They ask us to find the maximum height the rock will reach and use the work energy theorem. So I could say that similar to the first question, we should find some kinetic energy at the initial point and the final point, and also like the work done. Then we can find the maximum height, right? Hmm. Let's see. Let's think. So in this case, the rock will reach the maximum height. Okay, so let's imagine what's happening. We have the rock leaving the rail like this, right? Then it's go up, 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 up. Then it will reach the maximum height somewhere here, and then it will then drop down back to the rail. Okay, so is there any special information about the maximum height that can be related to kinetic energy? And kinetic energy means that related to the speed. And what about the work done? So I could say that the work done throughout the process until it go up there and then back to the rail is only the work that done by the gravity, right? Or more specifically here, that can also like be named like the weight because it have to do with the earth. So we good with the work. What about the kinetic energy? It mentions something with the maximum height that it will reach. Okay, so this is the point. Is there any special thing about this point? Okay, yes, right. You know it, right? That's about the V, right? So I could say like the rock could like move back, move upward, and you can see that along the way, like we saw for last time, we got this value about something like 30 meters per second, and then later it really slows down, right? Because the gravity is pulling it backward, it against the motion. So then it up to one point that the V should reach zero, right? Yep, it reached zero at the maximum height. Yes, that's why it stopped going. It stopped going further more, right? That's the maximum height it can go. It stopped going there, and then after that, the gravity will just like pull it back, and then it changed the direction. But we don't need to care about that part. We just need to care about this part here, the maximum height. So that's the most valuable information. Maximum height is when v equal to 0. And can you see that? So in order to apply the work energy theorem, we need to find two different time points, initial and final. And then we can see how the work have moved, have done through that, and how much displacement have been moved. So I could say if they try to find the maximum height, then it could be the distance from the ground up to this point when velocity is 0, right? This should be the maximum height. And that should also be the displacement for the rock to travel from the ground to where it get v equal to 0. And as we have done in the first question, we find the u here already, right? So if we know the u here, it means that we have the ki here, kinetic energy here. We know that the kinetic energy here is just 0 because the v is 0. So then square of it also like be 0. Okay, sounds good, right? So if we know ki and we know KEF, then we can know this one. Then we can find the work done. And the work actually is the weight times with the cosine 180 as we have analyzed in the first questions, times with the displacement s. So we can solve for s, right? Sounds good? Okay, so now let's follow that strategy, step plan, and rewrite our solution. Okay, you want to try yourself? Then maybe give yourself some time to try and then you can check with my answer in the next video. Thank you.